Today we are going to answer a fundamental question. What is a function? Simply put, a function is a named block of code designed to perform a specific task. Imagine you have a complex set of instructions. Instead of writing them out every single time, you group them together. Give that group a name and reuse that logic whenever you need it. This leads to better organization and much easier maintenance. I like to use the recipe analogy. Think of a function as a recipe for a specific dish. You define the steps once on a recipe card. Whenever you want that meal, you don't have to figure out the steps again. You just follow the recipe you've already defined. In coding, we define the logic once and use it as many times as we want. Now, take a look at this illustration. You can also visualize a function as a machine. Raw data or input goes into the machine. The specific code runs inside, and finally, it produces an output. This transformation is the heart of how functions operate. To define a function, we follow a specific set of syntax rules that tell the computer we are creating a new reusable instruction. Every function definition must start with the keyword def, which is short for define. Directly after that, you give your function a name followed by a pair of parentheses. This first line is often called the function header. Notice the colon at the end of that header line. It is absolutely essential. It signals to Python that the instructions for the function are about to follow. Also, notice the indentation. Every line of code inside the function must be indented to show it belongs to that specific tool. Think of this like building a custom tool for your workshop. You define how the tool works just once, and then you can grab it and use it whenever you need it later in your code without having to reinvent it. It's crucial to understand the distinction between parameters and arguments. While they are closely related, knowing the difference will help you debug your code more effectively. First, let's look at parameters, which we can think of as the blueprint. These are the placeholder variables you list in the function definition like length or width. They define what kind of information the function is prepared to receive. Arguments, on the other hand, are the actual data. When you call the function and pass in specific values like the number 10 or 20, those values are the arguments that fill the parameter placeholders. A function is a reusable block of code that performs a specific task. Instead of writing the same code multiple times, we can place it inside a function and call it whenever needed. In this example, the function say hello is defined using the def keyword. Inside the function, there is a print statement that displays a welcome message. However, defining a function does not execute it immediately. Python only stores the function and waits for it to be called. The function is executed when we write say hello. When the function is called, Python runs the code inside the function and displays. Hello, welcome to the world of functions. This example demonstrates the key concept of a function. Define the function once and call it whenever you want to execute the code inside it. Let's look at another example of a function in Python. In this example, we define a function called count to 3. Inside the function, a for loop is used to print the numbers from 1 to 3. Notice that defining the function does not execute it immediately. Python simply stores the function and waits for it to be called. Before calling the function, the program displays, I will now count to 3. Next, the function is called using count to 3. When the function is called, Python executes the code inside the function and prints 1, 2, 3. This example demonstrates that a function can contain multiple statements, including loops, allowing us to organize and reuse related code more effectively. Let's look at an example of a function with a parameter in Python. In this example, the function greet is defined with a parameter called name. A parameter acts like a placeholder that receives a value when the function is called. The function uses the value stored in name to display a personalized greeting. The function is called twice, greet Alice, greet Bob here. Alice and Bob are called arguments. These arguments are passed to the parameter name. When the function runs, Python replaces name with the value provided and displays the appropriate greeting. This example demonstrates the key concept of parameters and arguments. Parameters receive values and arguments are the actual values passed to a function when it is called. Let's look at how we get results back out. This is where the return statement becomes essential in our toolkit. The return keyword serves two main purposes. It immediately exits the function and sends a value back to the caller. Keep in mind that if a function finishes without a return statement, Python automatically returns a special value called none. To visualize this, think of a function as a processing machine. You feed in raw materials. Those are your arguments and the machine processes them. The return is the delivery chute where the finished product is handed back to you so you can use it elsewhere in your program. In this code example, our square function takes a number, calculates the result of the number multiplied by itself, and then uses return to pass that result back. This allows us to store the outcome in a variable or use it in another calculation immediately. Let's look at an example of a function that returns multiple values in Python. In this example, the function getUserDetails creates two variables, name and age. Instead of printing these values directly, the function uses the return statement to send them back to the caller. Return name, age. Here, the return values are assigned to two variables, username and user age. Finally, the program uses these values in the formatted output. This example demonstrates the key concept of the return statement. A function can send data back to the caller, allowing the return values to be stored and used elsewhere in the program. Now, we need to talk about where those variables actually live. This is what we call variable scope. In simple terms, scope refers to the accessibility of a variable. It defines which parts of your program can see or use a specific piece of data. First, we have local scope. When you create a variable inside a function, it belongs only to that function. It is created when the function starts and disappears when the function ends. Then there is global scope. Variables created outside of all functions are global. Think of these as being in the open air. Any part of your code can reach out and use them to keep it simple. Imagine a local variable is like a private tool locked inside a specific workshop. A global variable is more like a public street light that everyone in the neighborhood can see and benefit from. Let's look at a special tool called the global keyword. As we saw on the previous page, functions typically stay within their own local boundaries, but sometimes we need to reach out and modify a variable that lives in the main part of our script. Normally, if you try to change a global variable inside a function, Python simply creates a new local variable with the same name. To avoid this and actually edit the external variable, you must explicitly use global inside the function. This acts like a formal request to access the data outside the function's private room. Think of this syntax as a permission slip. By declaring a global variable this way, you are telling the program that this specific variable name refers to the one in the global scope, not a new one belonging to the function. However, there is a catch. In professional programming, we aim to minimize the use of global variables. If every function is changing the same global data, it becomes very difficult to track down bugs when something goes wrong. It's usually cleaner to use the parameters and return statements we practiced earlier. In this example, a variable x is created outside the function and assigned the value 100. This is called a global variable because it can be accessed throughout the program. Inside the function set x locally, another variable named x is created and assigned the value 50. Although both variables have the same name, the x inside the function is a local variable. It exists only within the function and does not affect the global variable outside the function. When the function is called, Python prints inside the function x is 50. After the function finishes, the local variable is removed, and the global variable remains unchanged. Therefore, the second print statement displays outside the function, x is still 100. This example demonstrates the key concept of variable scope. A local variable exists only inside the function where it is created, while a global variable exists only inside the function where it is created, while a global variable exists outside the function and is not affected by local variables with the same name.